Okay, today actually I want to share with you something about the the growing topic nowadays. Okay, because nowadays everybody talk about IoT, blockchain, Bitcoin, and so on. Okay, today actually this is I don't know new term or the old term, but I think this term started from 2018. Okay, we call it blockchain oriented software engineering. Okay. Okay, the agenda for today is we have four agenda. Okay, the first one is the overview of the blockchain, and then we go for the okay, what is the blockchain? What is the smart contract? Okay, this is actually the overview, and then we go for the architecture, and then we go for the software engineering for the blockchain lah. Okay, what actually what you can do? Okay, especially for the research. Okay, to apply the blockchain based or blockchain oriented in a software engineering. Okay, Mustafa. Actually, I'm not sure why this app is not working for the full view of presentation. Okay, maybe I update a new version and then suddenly the presentation view is missing. I'm not sure how to do that. Okay, okay, sorry for that. Okay, this is the actually the overview of the blockchain. Okay, this is actually the okay, the general what we call it, the description of the blockchain. Okay, as we know currently, the blockchain is widely used, especially for the currency lah. Okay, what currency domain. Okay, ataupun or we call it as coin. Okay, we have Bitcoin. Okay, we have Bitcoin. We have Ethereum, we have Ripple, and so on. Okay, so this kind of application actually apply the blockchain technology lah. Okay, and how they want to secure the transaction. Okay, how they want to secure the trust and so on. Okay. So actually the blockchain have three main criteria. Okay, we call it as immutable. Okay, the second one is transparent, and then the third one is auditable. Okay, immutable meaning that once the transaction is recorded into the block, okay, nobody can change that. Okay, that we call it immutable. So meaning that the security is very high. Okay, I can say that almost impossible to be hacked lah. Okay, at the back end level lah, at the back end level. Okay. So the second one is transparent. Okay, every transaction is very transparent. Okay, to all parties. Okay, because this one is the P2P network. Okay, this one blockchain technology promotes the decentralized architecture. Okay, not centralized. Okay, so that's why especially for the currency or banking right now, they use the centralized. Okay, in Malaysia, for example, we have Bank Negara. Okay, centralized management and everything, meaning that Bank Negara Malaysia organize or secure any transaction of the currency, okay, in and out from Malaysia to outside and from outside in Malaysia. Okay, but this kind of technology decentralized. Okay, we use the P2P network. Okay, meaning that everybody is transparent of the transaction and everybody must trust and everybody must agree all the data in the block. Okay, if one of the third parties is not agreed, so the transaction is not, okay, is cannot be executed. Okay. Okay, this is just a brief view of the blockchain explain. Okay, meaning this example, for example here, okay, how the transaction occur. Okay, for example, someone request for the transaction here. Okay, yang ni tak kisahlah, either currency ke, either supply chain ke, ataupun or supply chain food ke, and anything. Okay, this blockchain explain is just to explain how the transaction occur. Okay, once someone requests a transaction, okay, the requested transaction is broadcast to the P2P network. Okay, consisting a computer known as nodes. Okay, every block, okay, inside the blockchain, okay, will put into the nodes. Okay, and then the block itself have their own architecture. Okay, and then when the transaction enter in the network, okay, so all the parties need to validate. Okay, so at the validation level, the network of node validate the transaction. Okay, by using the specific algorithm and so on. Okay. So who validate the transaction? Okay, this is the minus term occurs lah. Okay, meaning that the minus will solve the very complex mathematical calculation. Okay, and then when the minus successful solve that problem. Okay, so the binance will get some what we call it, some piece of token lah. Okay, some piece of token. Okay, that's why in the blockchain or in a Bitcoin, okay, most of the user, okay, make money as a miners lah. Okay, of course miners have very low risk, but you need to have a very high end machine lah, okay, to do the minus and to do the calculation. Okay, once the transition is verified here, okay, either block, currency, smart contract, record, and so on, and then we will go to the okay, they will create a new block of data of the ledger lah. Okay, this is we call it the distributed ledger lah. Okay, inside the ledger we have a number of blocks. Okay, so and then once successful, the block will put into the chain. Okay, that's why we call it a blockchain. Okay, and then the transaction is complete. Okay, so this process actually is very complex. Okay, it's very complex, but as an end user, okay, we cannot see the process because the performance or the calculation rate is very fast lah. Okay. Okay, this is the overview of the blockchain. Okay, and then this is the architecture of the block lah. Okay, this is where your data of the transaction is stored lah. Okay, for example here we have 3D what we okay lah, boleh lah 3D. Okay, okay, the first one is the hash. Okay, and then previous hash. Okay, this one where you put your data. Okay, the data of the transaction. Okay, for example, you want to submit 1 Bitcoin. Okay, 1 Bitcoin. Okay, so the data is okay, the data is the Bitcoin, 1 Bitcoin. Maybe the second one is the address lah. And then the third one, fourth one is on depend on the programming lah. Okay, meaning that the data field where you put all the data that you want to transmit lah. Okay, so in the blockchain, it's about trust, and then it's about the transaction. Okay, trust is the most important thing lah. Okay, because this is where the philosophy of the blockchain, okay, the trust, the consensus, okay, the contracts and so on. Okay, so the earlier days of Bitcoin, okay, they only use the Bitcoin technology and so on. Okay, Okay, and a few years back, okay, one of the technology emerged. We call it as Ethereum. Okay, Ethereum introduced what we call it as a smart contract. Okay, smart contract actually is the enhancement of the existing technology, but actually the smart contract term or technology is actually makes the blockchain technology more powerful lah. Okay, the smart contracts. Okay, imagine you want to buy to sell your house. Okay, currently if you want to sell your house, okay, you will go a numbers of third party. Okay, for example, lawyer, okay, bank, apa lagi, agent, and so on. Okay, by using the smart contract, maybe in the future lah, okay, not today lah, okay. By using the smart contract, you can eliminate all those third parties, okay. Within that, you only communicate between the seller and the buyer, okay. Imagine, and then another one, the insurance company, okay. Insurance company meaning that, for example, you take an insurance, uh, when you buy a ticket, for example, at Asia, okay, you can choose the insurance, right? Okay, sama ada kapal terbang terjatuh ke, and so on. Okay, whether the flight fall down ke or the delay, okay, the insurance company will pay for you. Okay, for example, you want to go to KL, okay, your flight delay about 2 hours. Okay, in the insurance, in the contract, state that if delay 2 hours, okay, the insurance company will pay you 50 ringgit. Okay. So the current practice, okay, if you experience a delay to go to KL, okay, you need to apply for the claim lah. Okay, you need to fill in the form, you need to submit to the insurance company, you need to provide the proof and so on lah. Okay, maybe you can get your claim for 50 ringgit maybe 3 months. Okay, that absolutely is not uh, very late lah. Okay, so imagine by using the smart contract, okay, the transaction between the insurance company and between insurance company and Asia, okay, so they develop the blockchain technology and then they put the smart contract into the block. Okay, in the smart contract meaning that everything about the claim. Okay, the smart contract will automatically trigger if you experience a delay. Okay, how the smart contract now? Okay, the smart contract now actually from the ASIA system. Okay, the ASIA system. Okay, once you have a delay for 2 hours, okay, 2 hours, the smart contract triggered, and within the second, the claim will disburse into your account. Meaning that after this, if you delay 2 hours, you check your account, okay, already have 50 ringgit paid by the company insurance. This technology is already exist, but it's not applied yet lah. Okay, between the insurance company, between the flight company, okay, maybe insurance company, between the insurance company and car company, okay. Sebab kita ada kereta kan, so kita ambil insurans kereta, kalau nak claim maybe take 1 month or 2 months. Okay, maybe after this it takes only 1 or 2 minutes only. Okay. Okay, this is the smart contract. Okay, the smart where we put the smart contract? Actually, we put smart contract inside the block lah. Okay, smart contract is actually the piece of the piece of code lah. Okay, meaning that coding lah. Okay, meaning that you have contract. Okay, you need to code that contract and put inside the block. Okay, inside the block. Okay, instead of you have a hash, previous hash or data. Okay, you have another one. We call it smart contract. Okay, this is the overview of the blockchain concept and so on. Okay, now we go for the blockchain architecture in general. Okay, and in general, blockchain have 3 layer. Okay, we call it the application layer. Okay, blockchain layer and then the internet layer lah. Okay, as a software engineering discipline, okay, we don't put so much into the internet layer lah. Okay, actually internet layer at the infrastructure layer lah. Okay, so meaning that internet layer is most suitable for the network. Okay, the field of network lah. Okay, what we are interested is we want to see at the application layer and at the blockchain layer. Okay, usually at the application layer, where this is where the place of the smart contract lah. Actually, for the relation which define the variable of the rule, the set of rule set lah. Okay, so whenever you develop the smart contract, you need to set the behavior rule set lah. Okay, meaning that you have threshold, you have rules, and so on. Okay, at the blockchain layer, this is where the block, okay, for example, the asset, the record of the transaction, the ledger, okay, the governance of the data, okay, the governance of the elements of the blockchain and so on. And then the element of the P2P protocol, security and performance. Okay, this is where the blockchain, this is the blockchain layer lah. Okay, especially for software engineering discipline, we want to look in depth at the blockchain layer and at the application layer. Okay. Okay, this is the actually the problems occur for the for the Bitcoin application lah. Okay, we don't talk about the blockchain technology itself. Okay, as I said earlier, the blockchain technology itself is very secure. Okay, immutable and so on. The block is very secure lah, almost impossible to be hacked. Okay. So this problem actually happen at the application layer. Okay, meaning that the application itself lah. Okay, for example here, okay, the increasing of the popularity in the blockchain technology in the past 5 years, especially in the currency. Okay, as currently currency dominate. Okay, the blockchain application lah. Okay. So for my understanding, one of the susu formula company, if I'm not mistaken, Riso good. Okay, they already apply the blockchain technology, meaning that if you scan at the label of that product, you know where is the origin of the farm, the origin of the cow and so on. Okay, I think Friso. Okay, maybe you can check after this. Okay, so the increasing of the popularity of the blockchain, especially in the 5 years, okay, makes the agency to be the first in the market. Okay, fearing missing out. Okay, so that's why the consequences is that they apply the rapid software development. When they apply the rapid software development, so the lack of the software quality, of course. Okay, meaning that the application is not well tested. Okay, not well architect. Okay, maybe the architecture of the application is spaghetti. Okay, they apply the spaghetti code and so on. And then the unroll of the software development. Okay, where they get the requirement, okay, from the requirement they design and so on. It's not very systematic, and then they neglect the concept of the software engineering. Okay, so this is the problem for the 5-6 years. Okay, for example here the MT Gox, okay, lost about for 450 million. Okay, because this application hacked by the hackers. Okay, hackers hack the application, meaning that the hackers don't hack the block. The block is very secure. The hacker hack the application, meaning that the hack acquire the numbers of username and password, and then if the hacker get the username and password, okay, the hacker log in and then transfer to another account. Okay, so all the problems here occur at the application level. Okay, for example, Parity Wallet AC accidentally disabled and then 300 million lost. Okay, accidentally disabled. This one you can check lah. Okay, why this happen? Okay, especially when this problem happen, it happen at the code level. Okay, at the code level. Okay. So that's why from the problem here, okay, that's why the researchers around the world come out with the idea how to apply the software engineering into the blockchain domain lah. Okay, because the previous issues, okay, were highly related to the lack of software engineering practice lah, especially at the software development life cycle. Okay, and then the each level in the blockchain architecture is very relevant to the software engineering lah, except for the internet layer lah. That one more towards network or network layer lah. Okay, the 7 network layer. Okay, if you want to apply the software engineering practice, okay, you need to focus on two things lah. Okay, the first one is the software, the development of the software, and then the second one is the development of the smart contract. Okay, if anyone here want to jump into the blockchain research for software engineering, I suggest you go for the smart contract lah. Okay, because the smart contract concept actually very powerful lah. You can apply at the requirements engineering, especially the traceability. Okay, you can apply at the software process model, for example, agile at the okay, at the sprint process and so on lah. Okay, the smart contract. Okay, so the development of the software, especially at the application level lah. Okay, for example here, this application will manage the blockchain, will manage the application. Okay, will act as a wallet or exchange lah. Okay, for example, nowadays the very popular one is Luno lah. Dr. Naraini and Dr. Shaliza ada Luno.
Oi.
Okay. Okay, another one is the smart contract. Okay, currently how to code the smart contract? Okay, actually currently we use the Ethereum environment, and then we use the Solidity programming language lah. Okay, this one. After this, maybe you can explore lah. Okay. Okay, this is the papers 2008. Okay, actually the papers made some surveys. Okay, the software development practice of blockchain project lah. Okay, as we can see here, okay, I want to highlight here actually, for example, different technique to verify the correctness of the blockchain software. Okay, kalau kita tengok di sini, most of the developers, okay, focusing on the testing lah. Okay, unit testing. And then code review pun kita boleh cakapkan unit testing, okay, manual testing, and everything is about the testing. Okay, from here we can see that, okay, in the blockchain oriented software engineering, okay, if you want to start, maybe you can start at the testing level lah. Okay, at the software testing level. Okay. Okay, this is the number of software testing currently applied by the blockchain developer. Okay, especially they are focusing on the unit testing, and then some of them focusing on the performance testing, and then code review, okay, functional and integration testing, and so on lah. Okay. Okay, here here pun kalau if you see it's about the testing juga. Okay, at the testing level, and then this one of course at the testing level. Actually, you can check this paper. Actually, there are numbers of graph. Ada banyak lagi, but I just extract the most important thing lah. Okay, I want to say is that uh, if we want to embed the software engineering practice, okay, for the blockchain, okay, you must focusing on the testing lah, the software testing. Okay. Okay, for the needs of the software engineering lies into the seven area lah. Okay, the seven area. Okay, the seven area. Okay, the first one, the need of software engineering. The first one is the professional roles. Okay, the second one, the security and testing. I'm not sure about the security, but security and testing especially coupled together lah. Okay. Okay, so if I'm not mistaken, our undergraduate program, a new program, okay, will introduce one subject called secured programming. If I'm not mistaken lah. Okay, so the subject owner here, maybe you can start how to develop the learning outcome or the syllabus lah for the secured programming. Maybe you can embed the blockchain, okay, the blockchain oriented into that secured programming lah. Okay, that's my suggestion lah. Okay. And then we can go to the design notation, design patterns, okay, meta model, okay, ontology, microservices, and so on. Okay, this is another area that you can explore lah. Okay, explore a lot lah, because currently I think the developers of the blockchain don't use any specific software architecture lah. Okay, software architecture. Okay, so maybe the researcher can find out lah how to develop a new software architecture for blockchain lah. Okay. And then the needs for the modeling language. Okay, nowadays we rely highly on the UML. Okay, maybe you can make some extension at UML lah. Okay, UML. Okay, to enable how to design the blockchain based software lah. Okay, the need of the metrics. Okay, to measure the blockchain code. Okay, because if you want to measure the quality of the code for the traditional software and blockchain is very different lah. It's different. Okay, so that's why the needs for a new metric lah. Actually, there is a number of paper. Okay, make some comparison or review about the metric. Okay, saya lupa nak letak. Okay, nanti saya update this slide. Okay. And then the tools. Okay, maybe the tools to make the blockchain development easier. Okay, for example, the IDE tool for blockchain development. Okay, the testing tools. Okay, to test at the unit testing. Okay, to make some code review and so on. Okay, because one of the paper I read earlier, okay, the researcher state that until today there is no specific testing framework, okay, for blockchain. Okay, I don't know, because that paper 2019 or 2020, I don't know why either to this that framework is already developed. Okay, so maybe you can check after this. Okay. And then of course the process model. Okay, the process model need to go some major changes lah. Okay, for example, if you want to apply for example the agile scrum to develop the blockchain software, okay, you need to adjust something lah. Okay, at the process level. Okay. Okay, the first one is the professional role. Okay, this is the requirement how to be the blockchain software developer lah. Okay, you need to know about the back end, of course lah, how to program the block, the smart contract and so on. Okay, and then you need to be a very good front-end development application lah. Okay, and then you need to know about the smart contract development. Smart contract, this concept is very important lah that you need to know. And then you need to need the whole thing lah. Okay, we call it the full stack lah. Okay, the full stack. Okay, another one you need to know the about the business knowledge, the financial and the legal and so on, because blockchain is highly dependent on the contract. Okay, smart contract. Okay, you need to know this one lah. So actually for the software engineering practices, it's very suitable lah, because we as a software engineer, we need to know everything lah about the domain. Okay, not know everything. You need to be a fast learner lah. Okay, the level of adaptability is very high lah. Okay, for software engineering. Okay, that's why I cannot see any difficulty of software engineering student, okay, to jump into this area lah, the blockchain. Okay. Okay, the second one is the security and testing. This one I said earlier. Okay, if you want to focus on research after this, you need to focus at the security or the testing area lah. Okay, because here there is a lot of area you can explore lah. Okay, at the testing level. Okay, so for example, here client software built around the blockchain is not proven, trusted. Okay, this is I call it the client software. The client software, the application lah, the application level. Okay, for example, tadi lah Huobi ke Luno ke and so on. Okay, but the technology itself is very secure. Okay, so how to testing the smart contract? Okay. Even though the smart contract concept is very powerful, but the smart contract lack of the testing framework lah. Okay, meaning that nowadays until today there is no specific or standard standard framework how to test the smart contract. Okay, and then the solidity for smart contract, the program language for smart contract, no testing framework existing yet lah. For my knowledge lah until today. Kalau ada, if there any testing framework, okay, you can share with us lah after this. Okay, and then the needs of the automated test generation and code coverage lah. Okay, these two things is very important lah. Okay, why? Because once you create the smart contract and then you put into the block, you cannot change that smart contract. That's the problem of the blockchain lah. Okay, disebabkan terlalu secure. Okay, when you apply to the block, you cannot change. Okay, that's the problem of the blockchain. Okay, so as a software engineer or in the software engineering practices, you need to find out lah, to explore how to make okay, how to automate the test generation for the smart contract for the blockchain and so on. Okay, so in the future there is no problem like before lah, suddenly accidentally disable and then disable, loss of money lah. Okay, another one is the model based testing. Okay, since smart contract is a state-based by nature. Okay, smart contract is a state-based, meaning that date will trigger based on the input or based on the event. Okay, model-based testing actually is very good. Okay, to be explored lah. Okay, in order to enable the testing at the model level. Maybe Lokman expert on this lah, model-based testing, Lokman. Okay.
Maybe.
Maybe. Okay. Okay, this is the flow of the testing. Okay, as we can see here, starting from requirements engineering. Okay, the initiation, you need to produce the test spec documentation. Okay, based on the design, and then you need to test the API testing, block testing, functional testing, and so on. So many testing need to be tested. Okay, at the client software. Okay, at the back end there is no problem. It's okay, immutable. But at the client software or application level, okay, there is a lot of things need to be tested, especially security, okay, performance, and so on. Okay, this is about the security and testing. Okay, this is about the design notation. Okay, this is the paper that you can find after this. Okay, you can download and you can read lah. Okay, the first one is how they apply the design pattern. Okay, in order to develop the blockchain software lah. Okay, as we can see here, our expert here, Dr. Shaliza. Okay, Dr. Shaliza know about the composer. Okay, contract factory design pattern, apa lagi? Mediator design pattern, fakat, and so on. Okay, Dr. Shaliza.
Sorry, Doctor. Maybe another 5 minutes.
Okay, okay.
Okay. Adham, Prof. Wan. He is the expert.
Prof. Wan expert, Dr. Shaliza expert, Dr. Adila expert on the design pattern lah. Saya tak expert. Okay. The decorator and so on. Okay, how they apply. Okay. And then another one, this is the preliminary step toward modeling blockchain oriented software. This one is at the modeling level lah. Sorry, the diagram is not clear. Okay, this is maybe the researcher introduce some notation lah. Okay, to show the contract. Okay. Okay, so after this, maybe the one who interested at the notation level, maybe you can explore this one lah. Okay. Okay, and then there is need of the extension of the UML model or mathematical model. Okay, to design the blockchain software. Okay, currently there is no specific notation in UML. Okay, if you want to design the smart contract, the block, and so on, this representation is not existed yet. Okay, for my understanding lah. Okay, the metric. Okay, specific metric to measure the complexity, the communication, and so on. Because as I said earlier, to measure the code of the traditional software, okay, is very different if you want to measure the code for the blockchain software. Okay, and then the tools, they see the existing tools right now. Okay, most of the existing tools, for example, Get, Solidity, Remix, MetaMask, is for the smart contract. Okay, smart contracts. Okay, maybe after this you can explore how to develop the tools for the testing lah, especially for the unit testing. Okay, for the unit testing. Okay, this is the process model. Okay, this is Dr. Adila lah, Dr. Adila expert on Agile. Okay, maybe Dr. Adila can explore after this lah. Okay, how to implement the Agile Scrum or Kanban for the blockchain ni lah. Okay, example here, okay, yang saya baca, okay, they put the user story, and then inside the user story, you will have the acceptance test. Okay, every feature you will develop the user stories, and then when we do the sprint review with the stakeholder, okay, stakeholder must do the acceptance test, okay, during the sprint review. Okay, this one actually you can develop as the smart contract lah. Okay, smart contract for the user story and acceptance test. Okay, and then the smart contract for user story and acceptance test must be validated all the stakeholder. Okay, the customer, the product owner, the stakeholder, the developer, and so on. Okay, must validate this smart contract. If this smart contract agreed by everyone, then we can say that the user story for that particular features is successful tested or successful developed lah. Okay, so meaning that there is no issues after this, meaning that if you complete 10 requirement and then the next month the product owner said that, oh, this requirement is not acceptable. So that problem takkan terjadi lah if you implement the smart contract. Okay, because during the sprint review for that particular user story, okay, all the parties agreed, okay, validate, okay, that particular user story accepted, okay, for release. Okay, maybe Dr. Adila can explore about this lah, because I think I found that this concept is very interesting lah. Okay, to minimize the change requirement. Okay, to minimize the number of occurrence of change requirement. Okay, siapa-siapa yang terlibat dengan industri tahulah. Okay, betapa seksanya menghadapi dengan stakeholder lah. Always change the requirement. Kejap-kejap tukar. So if you if we can manage to implement the smart contract in the Agile Scrum, I think it will give the very high impact. Okay, not only at the knowledge level but at the industry level. Okay. Okay, so the conclusion is that the two important criteria of the blockchain, you must remember trust and transaction. Okay. And then the software engineering practices could enhance the quality of the blockchain software. Okay, so I found that there is two areas actually interesting to be explored. The first one is blockchain oriented requirements engineering. Okay, especially for the requirements traceability. Okay, maybe each requirement traceability starting from requirement design implementation. Okay, we want to develop the smart contract on that lah. Okay, to preserve the traceability. And then another one is the blockchain oriented testing framework lah. Okay, these two areas I think very interesting to be explored lah. Another one tadi. Tiga lah, agile. Okay, agile smart contracts. Okay. Okay, that's all for me. Okay, thank you.
Okay, thank you, Dr. Adham.
Okay.
Do we have any questions?
No.
I have one question.
Aduh.
Dr. Dayang.
Oh, okay,
Dr. Adham. This page in smart contract. Why it been called smart contract? Is it because the contract need to be smart?
The smart contract is called smart contract because the smart contract, as I know lah, is automatically triggered based on event. That's why this called yes.
So meaning that if we it doesn't mean that we need to apply any soft computing in order to make it smart.
No. Not necessarily
not
apply
necessarily.
No. Macam contoh saya bagi tadi, the insurance company lah, insurance company between insurance company and Asia. Okay, they put the smart contract into the block, meaning that if experience a delay about 2 hours, okay, the insurance company automatically triggered the smart contract inside the block and then transferred the money into the customer account lah, RM50.
Actually, Dr. Adham, actually some of the contract we already implement it in service oriented, but in smaller module, I think. This is a larger module and more security need to be considered.
Yes,
I think it's doable because anybody who's doing service oriented already look at that. I think it's a good research direction.
Yes.
Dr. Adham boleh share slide nanti?
Boleh.
Okay.
Yeah.
Nak tanya, kalau misalnya ada change request, maksudnya customer minta tambah modul untuk satu software. Smart contract ni dia macam mana dia akan membantu dari segi apa? Kita tak boleh charge klien ke kalau dia orang ada change request baru untuk tambah modul requirement baru dalam software. Saya nak tahu
kalau if you want to add a new requirement, it's not dia tak ada kena-mengena dengan smart contract. Okay, if you want to add a new requirement, okay, the problem is that if during the sprint, okay, for example, the during the sprint review, okay, the stakeholder, the product owner and the customer agreed on the, for example, 10 requirement. Okay, meaning that they said that, okay, the 10 requirement is accepted. Okay, but suddenly the next month, okay, the next month, the product owner said that, okay, this maybe one of the 10 requirement, they said that, yeah, this one ada, this one saya tak setuju. Okay, this one saya tak setuju sebab ada lack of parameter ke apa kan. But this is where the smart contract play the roles lah. Okay, meaning that the product owner cannot say that they cannot agree. Dia tak boleh dia cakap yang that dia tak setuju dengan requirement tu lah sebab the previous smart contract, okay, this previous smart contract, they said that they dah validate, meaning that they dah validate, dia terima requirement tu as acceptance lah during the acceptance testing. Okay, sebab I don't know lah sebab from my experience in the industry, actually there is a lot of argue about that lah. Okay, meaning that kita dah selesaikan 10 requirement tu, okay, maybe another 2 and 3 months, dia pergi balik dekat that requirement, meaning that I want to change this one. So when we argue on that, okay, when we argue on that, they said that I want to see the SRS. Okay, if they see the SRS, that's the problem occurs lah. Okay, maybe the lack of writing or the lack of information and so on. Okay, but the smart contract principle, we cannot argue anymore. Okay, because during that time everyone agreed. Okay, meaning that the current practice, the SRS only sign off one time only. Okay, kita ada SRS. Okay, the product owner sign, agreed sekali saja. But during the by using the smart contract, every sprint cycle tu dia kena sign off, and so on, using the smart contract lah. Of course, automatically occur lah, not manually lah. Okay.
This one is much more flexible lah, tak ada harm as compared to the previous one where you can really change accordingly as compared to if you have the big contract at the beginning. Dia lagi flexible lah. Tapi it need to be smart lah in order to catch up with the sprint yang berulang-ulang tu.
Yes. Bila saya cakap this one, especially we can imagine we have the very powerful software lah. It's not manual science.
Yes. It's impossible to be handled by manual management. It should be done automatically and need to be smart as well in order to like compare the previous requirement with the latest requirement or the previous change with the latest change. Because if we're talking about agile, dia berubah sentiasa kan.
Yes. To change dia berubah sentiasa lah. So maybe if Dr. Adila can explore this one, very interesting lah. Okay, any question? Another one, the testing lah, the testing part lah. Maybe after this pun I will explore on that part lah, the testing framework. Okay.
Okay, if there's no more question, I think we can proceed to Ain for the progress presentation. I think we have another 30 minutes. I was informed that the lecturers have another event at 3:30. Is that right?
Okay, thank you.
I'll share my presentation slides. I hope everyone can see my slides. Assalamualaikum and good evening. My name is Balqis binti Basmmi. Today I'm going to present on my progress
for research entitled Core Assets Development Approach for Service-Oriented Product Line. So my supervisor is Dr. Shalisa Abdul Halim, and my co-supervisor is Professor TS Dr. Dayang Nurhayati binti Aman Chawawi. Without further ado, my presentation will begin with an introduction, followed by literature review, methodology, and the results for Objective 1 and Objective 2. So as an overview, the development of technology has had a huge impact on industry. And in order to retain the competitiveness, environment of business are marked by a high level of change. However, delivering the need of developing a new system requires high efforts. Therefore, to achieve a feasible, quick and cost-effective system development, as well as in promoting an effective reuse, a systematic reuse approach must be adopted through these two reuse mechanisms, which are service-oriented architecture and software product line. So SOA allow flexible application composition quickly and cost efficiently, while SPL foster the development of core assets through systematic reuse. And SPL aided SOA by providing a systematic reuse approach, and the combination of these two paradigms are regarded as service-oriented product line. And two main activities involved in service-oriented product line are domain engineering activity and application engineering activity. So basically, domain engineering functions to analyze the reusable core assets, while application engineering provides the development of product from identified reusable core assets. And for this study, we are focusing on developing a core assets in domain engineering activity. So three sub-activities involved in domain engineering are domain scoping, which is the process of identifying, capturing and organizing services and functionalities of system, and is represented in product map. Next is domain analysis, where we group the commonalities and variabilities of core assets into feature model. And lastly is domain design, where an architecture is created with the variability of various services and is presented in reference architecture. Okay, so moving on to the problem background. So with service-oriented product line, systems are not developed from scratch. However, although SOPL offers reuse towards development of core assets, there are still uncovered challenges arises on how to identify only potential assets to be reused. So one of the challenges is the existing studies shows lack of systematic reuse approach for SOPL. Hence, the identification of core assets to be reused is not adequately addressed. Besides, an ideal domain engineering activity shall involve domain scoping, domain analysis, domain design, and domain implementation. However, only limited number of existing studies tackle domain scoping, even though it helps in increasing reusability. Same goes for domain analysis. Only limited number of studies emphasize on grouping commonality and variability, and there are no critical study on grouping the commonality and variabilities during domain analysis. And last but not least, there are various kind of representation for reference architecture, but shows lack of systematic technique in designing the reference architecture through service-oriented product line. So here I highlight three main problems for each activity that this study aims to solve. So in terms of domain scoping, there are lack of study that tackle domain scoping as the first step in domain engineering activity, and current scoping methods are not sufficiently documented in product map. And besides, in current study, all features will be reused without taking into account about the structure of the developed system. So the measure indicator of success for software evolution is the extent to which the software system can endure changes in requirement while leaving the architecture of system intact. So it is called an architectural stability. So this concept is still far from being used in current research, and many architectural stability related questions remain unanswered, uncovered. Thus, we explore perspective in handling the problem and come out by implementing trade-off analysis that lead to reduction of effort while address the organization's real needs or preference. Same goes for domain analysis. Current studies show lack of detailed explanation on the grouping core assets into commonalities and variabilities. So these challenges need to be put as one of the main priorities, as it is the fundamental of system development and the main output for core asset development. And lastly, for domain design, as I mentioned, domain design is where an architecture is created. So representation of reference architecture can serve different viewpoints of stakeholders. However, current study shows lack of support for designing variability intensive service-oriented system. So the primary research question that this study is trying to address are how to enable systematic approach of domain engineering activity, which comprises of domain scoping, domain analysis, and domain design in identifying reusable core assets for service-oriented product line. And a set of research questions are derived to support the primary research question, which is to study to what extent the core asset development through service-oriented product line is being studied, how identification technique of usable core assets for domain scoping and grouping of commonality and variabilities for domain analysis is being handled. Next is how to represent the identified usable core assets, and how does the applicability of proposed systematic reuse approach of identifying usable core asset is evaluated. So this research aims to enhance an existing systematic approach of domain engineering activity, which comprises of domain scoping, domain analysis, and domain design in identifying reusable core assets for service-oriented product line. So the objective to support our aim includes to investigate the existing study of core asset development through SOPL implementation, to enhance an identification technique of reusable core assets for domain scoping based on trade-off analysis, and grouping commonality and variability for domain analysis. Next is to enhance variability representation for reference architecture in domain design based on the identified reusable core assets. And lastly is to validate the applicability of proposed systematic approach in core assets development for service-oriented product line. So this research will mainly focus on the domain engineering activity, which consists of domain scoping, analysis and design, and also the architectural representation in terms of reference architecture. So moving on to literature review. So prior to our experiment, a mapping study has been conducted, which results in this taxonomy. So three main components are discovered, which are the main paradigm, and most study has covered the implementation of the integration of SPL into SOA to support systematic reuse of core assets. And the next one is measure engineering activities followed by approach. So for the purpose of this research, we will focus on the integration of, on the systematic reuse for developing and identifying reusable assets. Okay, next, this table shows the results of study for domain engineering activity. So as we can see, studies show lack of complete domain engineering activity. So as you can see, studies show that, and the domain scoping are often neglected. There are also only few studies that emphasize on grouping commonality and variability as well as business process. And for output, reference architecture are often selected as the representation for core assets. And case study shows the most promising evaluation method for experiment of domain engineering activity. And moving on, this table shows the result of literature review for reference architecture. So first obvious key point that can be deduced from this observation are reference architecture are presented in several different layers or view. And as reference architecture are developed during domain design phase, feature model that is developed during domain analysis is usually used as the input to generate the reference architecture. But there are also some studies that use different kind of input criteria to generate the reference architecture. And that's the difficulty in integrating reference architecture into existing system are commonly discovered in most study. And lastly, reference architecture typically did not address variability in a systematic manner. Thus, this offers a room for improvement for upcoming studies in providing a reference architecture that can also support variability systematically. Okay, next, we move into research methodology. We map our research framework according to our problem and objective of this research. The first one will focus on these two main processes, which are domain scoping and domain analysis. So during domain scoping, trade-off analysis technique will be implemented that is justified by considering the priority of services through probability of occurrence. So this can be achieved by applying a weighted business process feature model. And as being mentioned earlier, architectural stability problems are not usually being covered by most researchers. And besides, as more services are being reused, maintaining the structural stability of a system may be challenging. And therefore, this trade-off analysis technique is a way to address the architectural structure of the system. And this technique may result in a more comprehensive product map, which contains a detailed information of the commonalities and variabilities of core assets. And the result in product map will then be used to produce a feature model during domain analysis. So from feature model, we move into domain design, where the core assets is being represented in a form of reference architecture. So our reference architecture will consist of multiple view representation that involve logical view, process view, development view, and physical view. And to provide an architecture that can really represent the variability of core assets, we implement another representation, which are service variability meta model. And lastly, for evaluation, we want to see the applicability of our proposed approach in different case study by measuring the level of usability for each reference architecture. And here is our research process, which consists of 3 phases altogether. We begin with phase 1 for domain scoping and domain analysis, followed by phase 2 for domain design, and phase 3 for evaluation process. And for now, I've only done an evaluation for objective 1, which is to measure the usability of identified core assets. So there are 2 measures that are being taken into account in this study for objective 1. So it includes the measure of functional commonality to measure the average commonality for each functional feature in the core assets. And the next one is modularity, which is to measure in what extent a core asset is independent from other core assets. And moving on to my initial results of objective 1. For objective 1, the main product would be a feature model of the domain-specific application. So it begins with deriving all core assets of the domain. So my case study is the patient navigation program in Malaysia hospital. So the list of services and its ID is depicted in the first and second column of this product map. So this product map also includes instances of services preferred by user or organization to determine a possible configuration is needed to identify a set of potential usable core assets. So ABC represent three different stakeholders that each have their own preference or different requirement. Then we move into assigning probability of occurrence through weighted business activity set, WBAS. So in order to get a value for WBAS, all identified services are transformed into this business process feature model using this BPFM is generated using ADO as development tool. So from BPFM, we can assign a weight by referring to the variability type from this probability of occurrence table. And the result is being represented in the product map, which I include another column for the value of the variability value. And from here, we can proceed into trade-off analysis technique to derive a set of potential usable core assets. The trade-off analysis starts with prioritizing services by following the WBAS value earlier. So from there, we perform a normalization for added services and stability. So the ultimate balance between the rising for value of composition and lowering the stability is established from this normalization. And in choosing a set of usable core assets, only the best result of trade-off analysis is selected, which are those with a close value between AAV and the stability value. So here is the selection that has been tabulated. We can say that from this table, it can be easily ensure that all preferred and required services by each stakeholders are selected after careful experiment is carried out, after the trade-off analysis is carried out. So here is the feature model for the identified reusable core assets. So basically this is the output for domain analysis for the objective one. And here are the results of reusability evaluation between output from an existing study and output resulted from our proposed approach. The functional commonality from our proposed approach shows a slightly higher result than an existing study, and this can be implies that the reusability of identified core assets increases with a proper step during domain scoping and the implementation of trade-off analysis techniques during the domain analysis. And on the other hand, results for modularity of both approaches are the same. So it implies that both approaches are well modularized and can support high cohesion and low coupling. So next, we move into the initial result for my second objective, which is the representation of reference architecture. So to this extent, I've completed my first initial multiple view reference architecture of context diagram, and then the process view, which is represented in a form of activity diagram, the development view, which is represented in package diagram, and lastly, the physical view, or as in the deployment diagram. So all of these diagrams are by referring to the application architecture guide, and still need to be refined accordingly to address the variability of core assets. So I'm still currently doing the representation of reference architecture to complete my second objective. And last but not least is my plan for thesis submission, which is currently I'm still in the middle of completing my objective 2, which is to design the variability of the core assets. And I guess that is all for my presentation today. Thank you.
Thank you, Ain, for the presentation. Do you have any question? No question?
Assalamualaikum, Ain.
Salam, Doktor.
Okay, Ain. Just wonder, based on your proposed work is approach, right?
Yeah.
Okay, can you highlight the gap in existing work and how you can contribute?
Okay, the existing work that I'm referring to, the first gap is they are proposing a product line architecture while I propose a reference architecture. So the difference between product line and the reference architecture is reference architecture provides a multiple view for different stakeholder instead of product line architecture, which it only serve a small representation of system family. So there is one gap that I'm trying to cover. And in terms of domain scoping process, the existing study only refer to the requirement of solely on the requirement of the stakeholder without taking into account other factors such as how the reuse core assets may affect the system once one is being reused. So I'm trying to include that component where I want to include the trade-off analysis, which helps in maintaining the architecture of the system, even more or regardless of how many services are reused. There is the gap.
Okay. Very detailed answer, very good. Okay, all the best to you. It's just that just now, in terms of writing, I see the table related work, you write the the first and the middle initial of the authors also.
Oh, okay.
So I hope because you are about to write your thesis, right? So take note on the citation that it should be by last name only. Maybe in the slide only. Yeah, maybe your thesis is correct. But if you don't realize that, I just highlight lah because that will be part of us to highlight when we become examiners. So since I see it today, I just share. Okay, good.
Thank you, Doctor.
Yeah, good. All the best.
Thank you, Doctor.
Do you have any more questions?
Assalamualaikum, Ain.
Salam, Doctor.
Referring to your slide where you compare your modularity with other modularity just now, you compare with one existing work, which is published in what year? I forgot. Yeah, can you open back? Because it showed the same modularity percentage, and then which is you perform better in terms of
Functional.
the function. That's like okay. 2013. This publication is a conference publication or journal publication in
Journal publication.
2013, and then what is the artifact that they propose there? Is it they propose exactly the same or similar or equivalent approach as what you have? What is the major difference between your approach with the approach proposed by Eisenberg?
One major difference is Eisenberg proposed a product line architecture while I propose a reference architecture. And I also enhance in terms of domain scoping process. The domain scoping process.
Because that one is 2013. Any extension been done by Eisenberg since 2013 up to today date?
Oh, I didn't check on that, Doctor.
Okay, please trace because it's already like 7-8 years. Do some more tracing to see whether he or his group coming up with better solution. Then we can have a look at the solution. Okay, that's all from me. Thank you.
Thank you, Doctor.
Okay, if we don't have any more questions, thank you, Prof. Daya and Dr. Shaida for the questions. If there is nothing else, we will end our curriculum for today. Thank you, everyone, for your participation, and see you again in the next curriculum. Assalamualaikum, and you can leave the meeting now.
Waalaikumsalam, Luqman. Thank you, Luqman.
Welcome.
Thank you all.
Thank you.
Salam and thank you.